That's pretty cool. Hi there. Hello there. There you go. Hey, my name is Matt Williams, and I'm an evangelist at Datadog. Ooh, wow, that's really cool hearing my voice that big. You know, I was told that this theater was built for the Phantom of the Opera. And there's all sorts of cool looking places to go. The theater, the stage goes back like 50 feet. It's really amazing. This talk is about monitoring and about Lambda. And I think you're going to get a lot out of this. Now, at the end, I'm going to try to save some time for questions. And the coolest question I get is going to get a pair of these. Oh yeah, socks. They are, I didn't even know these existed until about 3 minutes ago. And they are Datadog socks. I have to show you, I really like socks that are this color. These are my Monotorama socks. I'm super excited about my Datadog socks. So, no underwear yet. We will think about that. It might be a little messy. All right, so you're here to learn about Lambda and about monitoring. Yeah, you see the title. You've seen my name and my title, Evangelist. I'm curious how many of you know who Datadog is. That's a lot of hands. That's awesome. You know, I've been a Datadog employee for about 2 years and a bit, and I've done a lot of talks. And early on, that number was a lot smaller. So it's great to see so many of you that know who we are. Now, I'm curious how many of you are actually customers of Datadog. That's awesome too. Cool. Now, for those of you who did not raise your hand, I am kind of curious. How many of you are using some sort of monitoring platform, whoever it is? Great. Monitoring is super important. So I'm so glad that you are monitoring everything. You should be monitoring everything. You should be doing that. Now, how many of you enjoy using that monitoring platform? I don't see quite. OK, one person raised 2 hands. He doesn't count. He has disqualified himself. But I didn't see a lot of hands. How many of you find that monitoring platform, I don't know, easy? Even the 2-handed guy didn't raise his hand. So, OK, that's interesting. And you know, how about you've got your Nginx server, let's say Apache servers, and somebody's complained that one of them is performing poorly. How many of you can find the information that tells you which Apache server is down or running poorly and can use that information quickly? Oh, that's actually pretty good. OK, well, that's more than I expected. So at Datadog, we're a SaaS-based monitoring platform. And we think that monitoring should be fun. I don't know about fun, but at least enjoyable. It should be easy. It should be, you know, you shouldn't have to spend a lot of time making sure your monitoring platform is running. It should just work for you. And that's why we've built Datadog, and we hope that you'll be customers soon. Now, this is not, OK, yes, I work for Datadog, but this is not a Datadog session. I had to tell you a little about who we are, but I don't want to spend any more time talking about, I want to talk about Lambda, and I want to talk about monitoring, and that's it. I might bring in some Datadog a little bit later. But I want to show you what my plan is for this session. So I have a plan. There we go. I've got 4 things I want to cover. I want to make sure you understand the basics of AWS Lambda. You've got to be in the right spot to touch that. Make sure you understand the basics about Lambda. I want to make sure that you know how, whoa, that was crazy. It caught up. OK, this is very touchy. Just once. I want you to be able to add Lambda to your infrastructure. I want you to understand monitoring 101, at least the too long didn't read version. And I want you to see how to take those 2 great ideas, kind of like that old classic Reese's peanut butter commercial. You know, take the really great chocolate, which I guess is the monitoring, and the really great peanut butter, which is the Lambda, and crush them together and monitor Lambda. OK, maybe a weird analogy there. So what is Oh, actually, I got one other question. How many of you are the coders, the people who like JavaScript, like Python, Ruby, all that? Oh, awesome, awesome. You're going to get a lot out of this session. Now, how many of you are the thinkers, the people who are going to decide where your company's going in the next year or so? Got a few of those, and you're going to find a lot out of this session as well. So, first off, what is Lambda? Lambda, you can kind of think of the next stage in this long progression that brings us to now. That's a super cool screen. So first off, we start off with the physical boxes. You know, back, I don't know, a number of years ago, the way you'd start is give Dell a call. Hey, Dell. Hey, Matt. Hey, Dell, can you send me a box? They'd bring you a box, a big cardboard box. You take your server out of the box, and now you got this big thing. It's got some depth, some width, some height. And you plug in the electricity, you plug in the network, and you turn on the cooling to keep it cool, keep it running. And then you load up the operating system, you load up the different applications. Oh, maybe you don't want to load up too many applications because you want to have some sort of security barrier between them. So you call up Dell for another box, and you put another one right next to it. So that's great, except I'm paying for a lot of stuff going in, and I'm actually only using maybe 10% of the box most of the time. I wish I could do more. And so along comes an idea of virtual machines. And now I've got these virtual machines. They're really cool. They look like, when I log in, they look like a physical box, but they're nothing to them. But I can load up multiple virtual machines on that physical box, and that's awesome. And it looks like the same, but I still have that physical box, and that kind of sucks. I still have to pay for the power. I still have to pay for the cooling and all that stuff. And along comes this little company called Amazon. You might have heard of them. And they come up with this idea called instances because the idea of instances, you know, they've got all these servers to support their little bookstore that they're running. And I think, hey, we're building up this electronic bookstore, online bookstore for Black Friday or Cyber Monday or coming up to Christmas, and the rest of the 350 days of the year, nobody cares about books. What's up with that? Maybe we can sell off these instances and make some money there. So they start doing that, and you know, we've all bought into that idea. We're all using EC2 instances to handle our stuff. And an EC2 instance is just a virtual machine hosted by Amazon. And that virtual machine I log into, it looks just like that virtual machine. It looks just like that physical server, but I don't have to worry about the physical stuff. I don't have to worry about the electricity and cooling and that kind of stuff. So that's awesome. But now I'm paying this fixed price, which is super cheap, but it's still a fixed price, and I might only be using 10% or 20%. How do I get more value out of that? And along comes the container. Oh, it's going to save the world. The containers, I can load up multiple slivers of functionality onto this VM, this instance, but I still have some of the same problems. I still have to pay for that VM, that instance. So the container didn't really solve that part. I still have to do all that. I still have to maintain an instance. I have to make sure all the stuff, patches are done and all that kind of stuff. So I'm not really solving all my problems. But the Holy Grail is here, and it is Lambda. So Lambda is amazing because all I have to do is write some code for my function, push it up to Amazon, and Amazon sprinkles a little pixie dust on there, makes some magic happen, and puts my Lambda function into a container, which is on an instance somewhere, and my stuff just runs. All I have to do is write that function, and that's it. Life is easy. It's just magic. It's just magic. That's really the goal of my presentation, to convince you that Lambda's magic. Okay. So I have a few concepts to run by you, make sure you understand. Here's my first concept. Totally Lambda related. I'll have you notice. Now, I don't know what you're thinking about this slide. You might be thinking about Roy Rogers, you know, cowboy, actor, rides on his horse, does stuff. Yeah, you might be thinking of that. You might also be thinking of that restaurant, that Marriott created back in the 50s and got Roy Rogers to sign his name away. And yes, we can use your name. That's not what I'm thinking. I'm thinking that Lambdas are trigger-based. Okay, so it's trigger-based. So basically, it waits for something happening in the Amazon ecosphere. And wait for that to happen, S3 file shows up. Kinesis stream, new stuff shows up there. And when that happens, it triggers a Lambda function to run. Cool. And if I load up one file on S3, I get one Lambda. If I get 1,000 or 10,000 files on S3, I got 10,000 Lambdas, sort of. I actually get 100 because right off the bat, AWS puts a limit of 100 Lambdas at the same time. You can just call up AWS. They'll increase that limit. That's really to protect you from the stupid things that you are going to do when you first get started with Lambda, because you are going to have it trigger way too many, and you might actually get a pretty big bill. So practice a bit, learn how not to do those stupid things, and then up your limit, and you're good. OK, I've got another concept I want to run by you. Any thoughts? Yeah? So what are you thinking? You might be thinking of countries. It's a global thing. Yep, Lambda you can use all over the world. There's locations, many Amazon data centers that support Lambda. That's awesome. But I'm actually thinking about the fact that it's stateless. OK, a little bit of a stretch on the map, but it is stateless. So the idea is, when you load up a Lambda function on it happens to be running on a container, when that function is done, that container goes away. Poof, gone. When you start up another function, there is a 99.9999999 chance that it is not on the same machine. Anything that you save locally is gone. The state that you might have saved locally, gone. Don't have access to it. You need to build your Lambda functions so that they are stateless, because you can't rely on that local stuff to be there. I got another concept. I got two more after this. Two more, including this one. OK, come on. There we go. Huh. OK, what are you thinking here? So, well, that's a good idea. Modular, maybe. But I am, by the way, some of you might not know what this is. This is Fabo. Fabo is all over the Netherlands, and maybe Belgium as well. I used to live in Amsterdam. I lived in Amsterdam for about 9 years, which is awesome. But I lived in Amsterdam, and when you walk around Amsterdam, even as a tourist, you walk around for a day, and you're going to notice at least two things. You might notice a few other things, but I'm not going to talk about those here. You're going to notice at least two things. And those two things are that there are Dutch everywhere, because, hey, it's their country. And all the Dutch, that's not one of the things. All the Dutch are gorgeous. They're beautiful. They're beautiful people. And they're all thin. How did they do that? I don't know. I am a little bit less thin. And I walk around. In fact, you look around, you see other people who look like me, and you will see, American. Yep, cool. So there are these Fabos, and you walk into a Fabo, you walk up to this wall of boxes, you plunk in your euro, you open up the little door, you pull out your burger. It was probably made 2 days ago. It's hard in all the wrong places, and you take a chomp out of it, and it's not the best burger, but the Dutch are flocking over it. And you go to the next thing, and you plunk your euro in, you open up the door, you pull out your frikandel, your sauerbraten, sorry about the pronunciation, all you Dutch in the audience. You pull out your Mexicano, your filet American, all these things that are deep fried in the most unhealthy way possible, and everybody is thin. It's so unfair. Anyway, that's a slight diversion. What is the concept here that relates to Lambda? It is serverless. Hey, there's no servers. A little bit of a stretch. There are no people. There is that guy way in the back. He's doing the fries, so he there's kind of a server, and there's people somehow that populate these boxes that are disgusting. Oh, the boxers are disgusting. I'm sure the people are fine. But it is serverless, and Lambda is serverless too, at least as far as you're concerned, because there is a server, of course. That's obvious. There's a container, but you don't have to worry about that stuff. That's Amazon's problem. Let them figure it out. I got one more concept, last concept. You might be wondering where I'm going with this, like all the others. So you think about the phone network, the PSTN, Public Switch Telephone Network. You go into any city, there's probably at least one central office or maybe multiple central offices, and they're filled with these switches, these big boxes that, actually I hadn't seen a switch in a long time, but they're probably boxes that electronic switches are changing, connecting different phone lines to different phone lines. You pick up your phone, you want to call your grandmother in wherever your grandmother is, and you're going to go through many of these switch locations. But before they had those electronics, they had people making almost nothing. And so here we have this long stretch of women who are trying to connect Aunt May to Grandma Jenny in some other city, and making those connections, so eventually those two people will talk. But what I'm thinking about with Lambda is concurrency, because basically concurrency is doing multiple things at the same time. And I talked about S3, you load up a file, or you load up 10,000 files. Now I'm going to get 10,000, once I've turned off that limit, 10,000 Lambdas all running at the same time, all doing your job. Awesome. Okay, those are my 4 concepts. Wasn't that fun? So what is a Lambda function? What is a Lambda function? I talked a little bit about Lambda. Now what is a function, or Lambda function? Well, first off, it's your executable code. That could be running JavaScript using Node.js, or it could be Python, or it could be Java. And it's your executable code that's running in a container, that's running on LXC, which is running on Amazon Linux, either as an instance or a physical box. I'm not sure about that part. But all that, everything past your function is hidden to you. All you have to do, that's Amazon's problem. All you worry about is your executable code with no restrictions. You can do anything you want in here. You can load up modules from all over the place, do anything. I'm pretty sure you can do pretty much everything. Yeah, maybe some illegal things you shouldn't do, but you pretty much have no restrictions. And price is based on execution time, quantity, and memory. Basically, and there's a free plan, which is awesome. You get 3.2 million memory seconds per month. Now, what's a memory second? You basically, most of the Lambdas will start off at 128 megs memory. And so you do 128 times 1024. That's your amount of memory. And then you calculate how many times did your Lambda execute. Let's say 10 over the course of the month, really light Lambda. And each one takes 10 seconds for some reason. So that's 100 times 1024 times 128. You add up or multiply that number together, and as long as it's below 3.2 million in that month, hey, Lambdas are free for you. So it's pretty awesome. You can do a lot of stuff with a Lambda on the free plan, and that free plan keeps renewing every month. It's not just for the first month to get you addicted. You keep going forever. Awesome. So what can trigger a Lambda? There's lots of things. Let you kind of peruse the list, but the things I'm most excited about are files. S3. S3 is a great one. The demo I'll show later today, or later this afternoon, this hour, is going to be based on S3. Internet of Things. There's Echo, the Echo Dot. We all have, I think we all have one of these in our bag or wherever we left it last night. And these are amazing. We got it with our jackets. And in fact, I actually have a Dot that I bought a few weeks ago, and I have in my kitchen. And when I'm cooking, I say, hey, Alexa, start a 45-minute timer. It's awesome. It's like, oh, so cool. In fact, I bought it because I wanted the Echo. So I bought the Dot because I wanted the Echo, but this is kind of like the gateway drug that convinces my wife to actually let me buy the Echo. I'm really excited. I think she's bought into it. But whenever I learn any new technology, it's helpful to get some examples. I've talked about wishy-washy, hey, these are things you could do, but it'd be great to see actual examples. So I got a few examples which I think are amazing. The first one is Goad. Goad is a Golang-based load tester to bang on your web server. And the idea is you do some configuration, say which regions you want Lambdas to run and start pounding on your server, and start the application, and it creates those up to 4 Lambdas in different regions. And when you say go and say how many times you want to pound on it, it will start pounding on your server from all those regions, and it could do it randomly, and there are lots of options. It's kind of like distributed version of Siege, or there's other tools like AB and like federated Siege that will let you. I've never gotten those federated ones, distributed ones to work, but Goad is just super easy. Install one command, it just works. It's super cool. Here's another great example, Benchling. They did a press release about Benchling, I don't know, a year ago. I still think it is an amazing example. Benchling is a software company. They do software for academics. They do software for research institutions. And they provide notebooks, interactive notebooks, and grading tools. But they also provide a CRISPR search for searching the human genome. And the product guarantees a response within a second. Now, they had it based on an older infrastructure that cost them thousands per month. But it couldn't really scale all that well. It was kind of difficult to work with. And they had, a couple years ago, a year and a half ago, Lambda's only been around, this is like the 2-year anniversary. So they had this summer intern start. An intern was only there for a few months, and he started working on this project and was able to recreate that old infrastructure in Lambda, and there were 2 major differences. One of the differences is it scaled a whole lot better on Lambda than it did on the other infrastructure. The second difference, instead of having to pay thousands a month, they paid $60 a month. Thousands? $60. That sounds pretty good. So there's a lot of other great examples that I really find interesting. BitTorrent trackers, I don't know, there's some people like that. I, of course, never have touched BitTorrent. One thing I find most interesting here is the skills for Amazon Echo. Now, I have not seen the expo floor. I am a speaker. I don't have rights to see our booth until the expo floor opens. I don't know why. But usually on the show floor at different summits, they have a booth for the Echo where you can build a skill right there. It takes like half hour. You can build your own skill, and it creates a Lambda in the process. Amazing. I hope it's there today or tonight and tomorrow, and I hope you have time to play around with that because it's amazing. And of course, now you've got a dot, so you have no excuse not to build this stuff. Okay, so AWS, Amazon has some best practices that you should implement when you build out your Lambdas. First off, write stateless code. Hey, this function is going to be stateless. Make sure you're writing code that knows that doesn't lock on some limited outside resource that you need to use. Make sure that you're declaring all your variables locally within that handler, just try to keep things as simple as possible. Make sure permissions are set right, read and execute, Rx. Now, if you're using some sort of framework, usually those frameworks will take care of that for you. But if you're doing the command line, then make sure Rx for the JavaScript files and so forth. Minimize startup. Make sure that your functions are just taking some input, doing something real quick, and spitting it out. Don't do a lot of startup stuff. Keep things as simple as possible. I love the fact that Amazon is saying one of the best practices is to monitor. I'll give you a second. That's awesome. They say monitor because they want to make sure you're monitoring the latencies, how is your function doing? Can you make it better? Because you're being charged based on how long these functions run. Can you make them shorter? So monitor them. You can't make something better unless you know what's going on. You have to monitor this stuff, which, of course, you all know, because most of you are monitoring, which is awesome. And then this is going to be super addictive. Once you've built your first Lambda, you're going to be creating them all over the place. They're going to be I used to work at Microsoft, and at Microsoft, I was a product manager in SharePoint, and one of the ideas of SharePoint was to solve the problem of front page sites, because people were building them all over the place. There were ones over there and ones over there. They all got old, and nobody could control them. And so SharePoint was, one of the goals was to solve that. And I think we got kind of the same problem with Lambdas. People are going to be creating them all over the place. You need to go in there and delete all your old functions, because you just try to keep things simple. So now I want to add Lambda to, add a Lambda. So show you how to add it to your infrastructure. Now, working with Lambda, it's easy. There are just 3 steps. Okay, maybe those 3 steps can expand a bit, kind of like development in general. I guess development in general is just 2 steps: write the code and debug it. Okay, maybe 3 steps: write the code, debug it, and deploy. Okay, maybe 4. Well, you get the idea. Really simple. Development is easy, right? No tough stuff. So with Lambda, write the code, because that can be put in one bullet point. Set up AWS. Okay, you got a GUI, you got frameworks, you got command line tools to do this. And then debug. That's pretty easy. So only 3 steps to do a Lambda. Now debugging isn't quite as wonderful as all the other things that you're using today. You can't use these interactive debuggers. You're relying on log files. I know you remember this back when you were in high school or grade school, when you first started developing stuff. So write console log or write line into a log file, and you're debugging based on that. Sucks. Anyway, that's how you debug. It'll get better, I hope. So let's get into a little bit of a demo. Now, I am here. My laptop's over here. But this demo is going to work through magic. OK, so there are a few steps involved with setting up a Lambda. I'm going to use the web GUI. The first thing is we go into click the big blue button at the top when we go into the AWS Lambda console to create a Lambda function. From here, we're going to get a blueprint screen. And we can scroll through these different blueprints. Blueprints are kind of like templates. Give you a launching point. So when I click on Next, I see this screen. I can click on that little box. I get my list of triggers that can trigger a Lambda. And this is a subset of the triggers that can do this. There's a few other places to go to get others. But what I'm going to click is S3, because I want to upload an image to S3. Sorry, let me a few more sips. I should have sipped more during that little snafu. OK, so here I get the choice of events. Because I'm doing S3, and a bunch of events that S3 can throw out. And I only care about when images get uploaded to an S3 bucket. So I'm going to choose put. And now I can choose a prefix, so basically a directory in my S3 bucket. And anytime a PNG file gets uploaded, then I want to trigger my Lambda. So I click on Next. And now I can choose a name. What do I want my function to be called? And what do I want my runtime to be? Now, I've got a few choices for runtime. I can choose Node.js 4.3, or Node.js, which is 0.10, or Java, or Python. Those are my choices. But you actually can do a lot of other things using a spawn or exec, trigger off a C++ program, or Golang application, or lots of other things. I'm going to go with Node.js 4.3, scroll down. I've got a point to put in my code. This is not your favorite IDE. This is just a place to write stuff real quick, assuming you already know what you're doing. Probably better off in Sublime, or Visual Studio Code, or Atom. And right there, copy and paste into here, if you're going to use the web UI. This is great the first time. Pain for doing lots of Lambdas. So you're probably not going to do a lot of Lambdas in here. But it's OK for our first one. We're all good. Scroll down, and you can choose the handler, the role. I already created a role in IAM, and now I can choose how much memory. This is the only real configuration you have when it comes to creating your Lambda is how much memory. And as you choose more memory, you're going to get more CPUs kind of for free. But memory is the one thing that you're really selecting here. You can also choose a timeout. How long do you want before it just gives up? And the default is 3 seconds. You might want a little bit more. And you can say, hey, my Lambdas always take 10 minutes. You can set it to 10 minutes. Click on Next. It'll show you a little confirmation, and then create the function. And now, if I had actually put some code in that text box, I would have a totally up and running working function. And that was all I had to do, which is great, except that's a lot of work. If I have to do 500 of these, I am not going to want to do this unless I buy or hire a cheap college student to do that for me. So there are a lot of frameworks out there, many, many frameworks that you can use to do this. A lot of the hard stuff, or not hard, none of this is hard. Do the kind of the grunt work for you. And 2 of them are really, really popular. There's Apex and there is serverless. I've spent most time with serverless. I think it is really awesome. I love being able to open up a serverless YAML file, enter in my CloudFormation template, enter in what I want my IAM roles to be able to set up all the things. I want to have a DynamoDB set up. It has these tables, and I want S3 set up in just the right way with these permissions, and I want to do all these things, and I want to deploy these 15 Lambda functions, which all have events that trigger it, that are actually on the API gateway from gets and posts and all that type of stuff. It's all in that serverless YAML file. I just run command, and it just magically appears. It's super cool. Now, I think Apex does that as well. I've just spent a lot of time with serverless. Now, if you wanted to use, you don't want to have all that other stuff. You just want to get the basics. Node Lambda is great for getting that first one up and running, just playing around, just use the basics. Node Lambda is awesome. Another one I think is really interesting is Go Sparta. Go Sparta supports Golang for your Lambdas. So you can write a Lambda in Go, and it deploys it, sets up a Node.js function that does a spawn out to your Go. I think that's how it does it. Of course, you could also use the command line as well. The command line is great. You can do everything that many of these frameworks will do, and to push out that Lambda. Awesome. Now, there are some gotchas. I was using Node for my demos. And if you're using Node and you're using native Node NPM modules, you're going to run into a little issue because Lambda runs on Amazon Linux. Now, I don't know about you, but my dev laptop or dev machine is a Mac. Maybe it's a Windows box. Maybe it's some other Ubuntu or some other Linux variant. I don't think you're running Amazon Linux for your dev box. I don't know. So there's a disconnect there. So, and that's going to cause some issues. Just trying to upload those native modules. Lambda's going to see, hey, what's this module created for a Mac? What's up with that? Easy way to get around that, just set up a new EC2 instance, load up some sort of Node version manager. There's NVM. I really like N, which is great, but you can use whatever tool you like. Makes it super easy to install Node 4.3, then install any of the native Node modules that you want, and then package them, zip it up, download it to your box, and do a deploy. So pretty easy to get around that kind of issue. And there's other tools for doing that, but here's something I went through to get my native modules working just right. Cool. So let me do a little bit more of a demo using Node Lambda. Node Lambda, really just 4 files that you need to deal with. There's package.json, which has what your dependencies and dev dependencies are. There's a .env file for your environment variables. Don't really need that. Event.json for having kind of a local, you can test it locally, and that's going to trigger the Lambda locally. And then index.js, which is the meat of your Lambda. And so here I've got my index.js. It's just a super simple, I've got a bunch of declarations at the top, followed by the meat of it. I've got basically doing 4 things. I'm downloading an image off of S3, converting it to a JPEG, resizing it into 4 different sizes, and then Scrolling down, and then at the bottom I see an upload, uploading it back up to S3. Not the most efficient way of doing it, but hey, it'll get it done. So if I want to run this, I don't expect you to read it, although it's a really big fuzzy screen. It's a really big screen, so some of you can probably read that, but I don't expect you to actually see this. Basically what I'm doing is npm run dry run, and when it happens, it's going to spit out a bunch of stuff. And this is what would normally show up in CloudWatch logs, but I can run it locally just to verify things are working. When I'm all good with that, I can do an npm run deploy that packages it all up and pushes it up to Amazon, and reports back saying, here's what I pushed up. When I've got my node module, my Lambda up on Amazon, I can come into the console, click on the monitoring tab, and look at invocations, duration, errors, and throttles. Those are the 4 metrics that CloudWatch collects automatically. And good water. And then over in the top left corner of the screen is view logs in CloudWatch. I can click on that, and I see all my log files, basically 1 for every minute that I had stuff going on. Click on any one of these, and I'll see the contents of that log file. Basically, exactly what I saw in the console before. Great. So that's pretty easy. Now I'm going to actually try this out using I like to use a kind of a Explorer clone called Forklift. Forklift is great because it supports S3 as well. And so I drag a file into my input directory, my image directory, and pretty quickly I'll see 4 directories get created on the other side, on the output directory: large, medium, small, and thumbnail. And I can click onto each one of those and see the different sizes. Yeah, I worked at Microsoft. I love seeing Active Directory. I don't know why I picked that one initially. OK, so now what happens when I add 100 files all at once? OK, there's a little bit of bottleneck because I'm uploading files to S3 and it's over the internet. But things are going up pretty quickly, and pretty quickly I see those different folders populating, and as I refresh my little browser here, I see those files getting created, and so there's many Lambdas that are all running at the same time, which is great, and so it's doing its job. Awesome. So that's a little bit about Lambda. That's how easy it is to get up and running with Lambda, and now I want to switch over to Monitoring 101. Now, Monitoring 101, that's kind of everything you need to know about monitoring. Monitoring's pretty easy. I want to make, as long as you've got kind of a framework in place. So I want to talk about that. And I could spend a while on monitoring. Hey, I'm working at a monitoring company. I could spend a long time talking about this stuff. So again, this is just the TLDR version. Too long, didn't read. Just want to cover it in a few slides. And I love starting off with this one. Here we are. That's mostly color accurate. Here I am driving along. Everything's all good. Rain's coming down. I happen to have looked just the day before, maybe actually the few weeks ago, looked at the tire pressure, maybe a few months ago, looked at the tire pressure. OK, it was all good back then. I saw that my tires were kind of balding, so that's not good. But I know that, and I know that it just started raining, so it's probably slick, so let me slow down a bit. I see my speedometer on my dashboard, and I see that, OK, I'm now at a good speed. I'm in the lines. Well, that's good. And all the other cars, they're in their lines too, so that's good. I don't see any lights come on, so that's good. So here I am. I'm collecting a lot of metrics about driving, collecting metrics, and the car is actually collecting a lot more metrics. It's a modern car. It's got a computer, so it's collecting all sorts of stuff about the gravitational pull on the tire. I don't know, all sorts of stuff. It's collecting a lot of metrics and just giving it engine light, or overheating, a few lights, the key metrics, pulling those key metrics out and showing them to me. And when I see these, I can avoid disaster and avoid big problems that might happen if I wasn't paying attention to at least those key metrics. Now, bad stuff could still happen, but I'm doing everything I can to avoid it. Kind of the same thing with monitoring your infrastructure. A little bit of a stretch. You should be collecting as much as you can about everything that's going on. You really should focus on, watch the key metrics, but collect everything, because collecting data is cheap. You should collect as much data as you can about everything that's going on within your environment. Not having that data when you need it, that can be really expensive, because now if you don't have it, you need to recreate the problem, try to let your monitoring system look at the problem now that you've recreated it. You may never be able to recreate it exactly the way it happened. Not having it when you need all that data can be really expensive. Now, the problem here is we're saying collect everything. I don't know about you, but for us, that's a lot of metrics. We have customers that are collecting 5,000, 10,000, 20,000 metrics, and they're getting updated every 15 seconds. 20,000 metrics every 15 seconds, what do I look at? It's hard to know. It's hard to know what are the key metrics to focus on. So we've come out with a long series of posts on our blog called Monitoring 101. Give you guys just the basics. Now, in each one of these sets of articles, there's one that is specific to our product, but the rest of them are totally agnostic. You can be using any tool and still apply these to that tool. So really great for understanding what do I focus on. And we also apply them to monitoring Postgres or Mongo or Cassandra or all sorts of other services. So check that out. But generally, in the first post, the first Monitoring 101 post, we came up with a framework of 3 buckets that are not there. No, they're not supposed to be there. Don't worry about that. So the 3 buckets first are work metrics, resource metrics, and events. Okay, so those are 3 buckets. Work metrics are throughput, success, error, and performance. Throughput might be requests per second, request process per second that your Nginx server does. Success, number of 200s, errors, number of 404s, and so forth. So those are the key things that you really focus on. Resource metrics just add context to those work metrics. Utilization, saturation, error, availability. CPU utilization is a common utilization metric that everybody looks at. You open up HTOP or TOP or some other tool, you're going to look at CPU utilization, and on its own, it's probably the most worthless metric to look at because it doesn't tell you anything. 2%, 98%, what's that mean? I don't know. But now, if I have throughput go from 1 million requests per second down to 2, and CPU utilization to go from 2 to 98. Well, that's interesting. I wonder what happened there. So it adds context to the work metrics. Same thing with saturation, which is going to be queue length, and errors and availability. And then events. Events also add context to everything that's going on. Code changes. Hey, I did a Jenkins deploy 5 seconds before everything went crazy with my request per second. Maybe they're related. I can't exactly say that caused it, but at least I have a place to start. Okay, so what do you look at? You focus on those symptoms, which are going to be the work metrics. Figure out what is the right threshold and page on those. Yes, you should be woken up for the right things that are going to be work metrics at 3 a.m. Use everything else to diagnose the problem. The work metrics, the other work metrics, the resource metrics, and the events. And of course, this isn't just a single level. You're going to start, say you're dealing with a WordPress site, and it's on Nginx. So you might look at the work metrics for the Nginx server, work metrics, resources, and events, and then dig a level deeper. You got MySQL. You got look at the work metrics, resources, and events, and then you dig a level deeper. Maybe it's file system, the work metrics, resources, and events, and maybe dig a level deeper to find the EC2 instance and the work metrics, resources, and events. Okay, so that's a little bit about monitoring. Well, let's move on to where we bring those 2 halves together and make a peanut butter cup. Monitoring AWS Lambda. That's what I meant. So we saw in the little demo the 4 metrics that CloudWatch collects automatically: duration, errors, invocations, and throttles. But chances are, if you're dealing with the image processing, you care about a little bit more than that. So there are 3 options for collecting metrics about what's going on inside of your Lambda. First off, you can create a custom metric and add that to CloudWatch. Awesome. Now, depending on what you're paying for CloudWatch, that's going to be updating basically every minute. And so if you send it 1 metric every minute, hey, awesome. That's what you're going to have. Now, if you send a second or third or fourth or fifth or 1,000th metrics in 1 second, you're basically getting a histogram. You're going to get a median, you're going to get a min, a max, maybe some other values as well. You're getting a histogram. There's a lot of stuff missing from that histogram. So you could also send a metric directly to your application, to your monitoring application. That's great, except one of the goals is to keep things as simple as possible. You don't want to have a lot of extra stuff in that Lambda. So try to keep things simple. So maybe that's not the best solution. It's going to add complexity and size. Or you can add a line to the CloudWatch logs. This is what you're doing for debugs, and this is what you can do for monitoring as well. It's not quite as sexy, but hey, it works. So that's what Datadog does. We rely on this line that people add to their log file, to the CloudWatch. And it has this very specific format. Monitoring in all caps, pipe character, time since the Unix epoch, which was, I don't know, 1970 or 60, when was that? Anyway, way back. And then a pipe, a value, what you actually want, what the value of this metric is, the type of metric after that, which is going to be a count or a gauge, followed by your metric name. So I could say Matt's cool lambda dot performance dot something. And that would be my metric name. Not a very good metric name. Ending it with something is not good. And then a pipe, and then some tags. I always add Matt demo to all my demos. That way I can see it's my demo. I also add a lot of other tags, and we'll see some of those in a second. So here's an example from the code that I showed earlier. This was the download part, where basically I grab an object from S3, and then I am calling two console logs to write this monitoring line. So let's look at one of them in detail. The first one says monitoring, pipe, and then the time since the Unix epoch. I love saying that word, epoch. And it's basically the date now function to spit out that timestamp. And then I'm setting a value of 1 because it's going to be a count. So value of 1, count, and then give it a name, which I've shortened here, and then a few tags. So I've called it demo mat, and I've got 4 of these sub-functions in my Lambda. I've got download, I've got processing, I've got conversion, and I've got upload. And so this is image function : download, which is going to be really useful in a little bit. Look at the second line, and I've got basically the same information, but I've got a timer for that second value, which is the third block, monitoring, date, and then this third block, which is the timer value. And everything else is exactly, and then the fact that it's a gauge, everything else is exactly the same. Now the timer comes from calling process HR time, and then calling it again on line 4 to get the total value spent for this particular thing. Not really much happening here, it's just a download. But then I'm able to use it, and I created a super simple, this is not, I don't want you to think that this is all that Datadog can do, but this is a simple dashboard, really ugly dashboard. I am not going to win any design awards. Thankfully, our designer who was taking photos of me modeling up here earlier, he has left the building, so I don't have to worry about him seeing this. But let's look at this in a little bit more detail. This is basically some stack bar graphs, and I have been able to call out each of those 4 pieces of the function, and download is taking up the least amount of time, which is great. And that brings me to the end of this session. I've talked a little bit about Lambda and what is Lambda and why you should care. I talked a little bit about how to add Lambda to your infrastructure. You saw that it was really easy. I talked about monitoring 101, with the basics of monitoring. And I talked about bringing those two sides together, how to monitor Lambda. Now, here is this QR code. You might be wondering why I have a big QR code. Basically, if you, all the cool kids can scan that and link them to a URL, which I should have memorized, but that URL is going to get you a GitHub repo that has a PDF of the slides as well as links to the code that I used in this session. My name is Matt Williams. I'm an evangelist at Datadog. Email is right here, mattw@datadoghq.com if you have any questions, or I'm on Twitter at technoevangelist. And I think that brings me to the end. Now I can open up to questions. If anybody has questions, there are a couple of mics towards the back, so you can ask those questions. But that's about it. Thanks so much for joining me.